Hi, I'm Brad Peebler, and in this tape we're going to be taking a look at general surfacing attributes in LightWave 3D. We'll cover concepts like Viper, the versatile interactive preview renderer, the preset shelf, surface samples, the general preview settings, and textures for surfacing as well. So let's go ahead and get started. We'll be using content that you'll find on your LightWave 3D CD. We know you like that, so you can follow right along with us. So let's go ahead and jump in. First thing we want to do is let's go ahead and load a scene. You can either load the scene from the File pop-up menu up here, or with Control-Shift on the keyboard held down, the left mouse key becomes a context menu pop-up. So I can just go here, File, Load Scene, and we're going to go ahead and go into our benchmark directory. So under Scenes, Benchmark, there's the Textures, and we'll go ahead and load that up. And this will just give us a generic scene with lots of different surfaces on each one of these different cubes. Okay, so first thing we want to do is, of course, open the Surface Editor, and you'll find that right up here in the top left under Surface Editor, cleverly labeled. So we'll open that there, and what you'll see here is our generic surfacing editor window. Okay, so there are a couple things I want to activate here before we get started. One is Viper, and the other one is the preset shelf. We'll activate both of these guys. Now these are global services that we'll find all over the application. Now right now we're using it for surfacing, and you'll see they actually come up saying Surface Preset and Viper Surfaces. When we activate these in other places like Hypervoxels or SkyTracer, they'll represent that in these panels, and you can use them for different plugins and different types of activities. But right now we'll go ahead and use them for the surfacing. So let's go and take a look at Viper. Okay, and these windows are floating, so we can move these around however we like. Let's just go ahead and move our Surface Editor here, and we'll go ahead and scale our presets window so we're not fighting with that. Okay, now the first thing I want to do is describe a little bit about the layout of the Surface Editor itself. On the top left here, you can see we have an edit by, a filter by, and then a pattern listing. All right, this controls this window here. In this window pane, you can see all the different objects we have listed in the scene. All right, and underneath each one of these, if we open the spinner, you'll see the surface that's associated with that. So you can see there's our cauliflower. If we open up checkerboard or chrome, you can quickly get a surface sample render of those different surfaces. All right, well, you can see that if you have a heavy scene, this is a pretty simple scene, and already we have a lot of different objects that can get kind of cumbersome to try and figure out what surface is where. So there's different ways to filter this scene file listing. For example, right now it's filtered by name, but we can also filter by texture. And if we tell it to filter by texture, now I can type in a portion of a image name. So let's say I know that I've got fractal reflections, so let's type in FRAC for frac, and it filters it down. So now only the textures using, or the surface names rather, using the fractal noise pattern are going to be listed. And so you can see if we look in the bump, you can see our fractal pattern there. If we go to our cauliflower here, and then there's fractal noises there as well. So it's basically just filtering out everything that doesn't have fractal in the procedural name or in an image name. Okay, the other methods to filter are based on a shader. So if you're looking for certain surfaces that use a shader plugin, you can do it this way, or only surfaces that are listed in the preview. And that brings us to Viper. So let's go ahead and explain Viper here. We'll go ahead and clear out our pattern so we can see everything on our list. This is our Viper window here, and what you can see is, first of all, there's very few settings on the Viper window itself. It sort of does all the work for you. You've got basically a setting for the preview size, so depending on the speed of your computer, you may want to turn this down or turn it up. I usually leave it right at that 320 by 240. It's a nice mixture between speed and resolution. The first thing I need to do, if I try and make a render here, it'll give me a warning that says Viper contains no surface data to render. Please make sure that Viper is enabled in the render options and then render an image. Okay, so what we've got here, the Viper window itself is going to give me a version of my image. So my rendered image will show up in that Viper window. But it's more than just a straight render. It's actually got extra buffer data that LightWave generates. So when we're working with our surfaces, those surfaces can be properly deformed around the skin of the model. Even though we're not working on a 3D model, we're working on a 2D image. So to create that, we have to activate the Viper trapper, basically. It's an enable Viper command on the render options panel, so that when we do the render, it captures that extra extra buffer data. Now the reason that's not always on is it adds a little bit of render time to your final renders, and we don't want to add that overall in your entire scene. So we turn it on one time, make our test render, and then turn it back off again. Let's go ahead and take a look at how we do that. Over here on the left-hand side of our screen, we have our render pop-up, and you can go to Render Options, and now you can see that in the middle of our Render Options panel is an Enable Viper button. So we'll just turn that on, and then I'm just going to use F9 to make a quick render, and it's going to render that out. Now I've got anti-aliasing on, so it'll take a second here. Okay, so there's our final render, and that's fine. You can see the nice high-res version of it. Looks good. Lots of surface samples here. So we'll go ahead and close that. And we can go ahead and close our render preview window, or render controls rather. And now you'll notice if I hit render, it shows me the same render in my Viper window. Alright, now here's the cool thing about Viper, or one of the many cool things about Viper. Because it's got that extra data in there, one of the things it knows about this image is what pixels relate to what surface name. So if I click here on this orange peel surface, you notice it selects orange peel over here. If I click on moon, it selects the moon. So without knowing what surface name is assigned to each one of these objects, I can simply click on it, and it'll select those for me automatically. So it's a real nice way to do selections. Now this brings me back to the filtering controls, and again you can see on my filter by here, I can set this to preview, and it'll only show me the surfaces that are in this window. Now in this case I've got my camera set up to see all the surfaces, but if I had rendered a version of this that only showed me perhaps these top 4 here, if I filter by preview, it'll only show me those 4 surface names. So it's a real good way to limit that. This is a real important feature when you're working with multiple users in a single environment. So you're working on a large-scale project. Many times, even though you have set up naming conventions for your project, if you get something very complex, sometimes it's hard to realize what surface name is associated with what object or what surface on the scene. So an artist can very quickly make a single frame render with Viper enabled. Then they can look at that Viper window and they can pick the surfaces just by clicking on the image that they want to edit. Alright, let's go ahead and take a look at some of the editing controls here. So again, our Viper window open, we can now use that to pick surfaces, but we can also use it to see in real time the changes that we make to our surface settings. You'll also notice that we have a little render sample sphere here, and if I make a change, let's just change the color here real quickly. So I'll go ahead and move this over a little bit. I'm going to go ahead and pick the cauliflower surface. Alright, and now you'll notice that if I make the change to the color, let's just change it down to kind of a pink, it changes this surface first and then the Viper window. Okay, watch again. I drag this down, this one draws, and then that one draws. You'll also notice that when I make these changes, it only redraws the Viper, or the currently selected surface rather, in the Viper window, and the other ones get a gray outline around them so you can see exactly what surface you're editing while you work. One little note here, you may notice what I'm doing on the surface color is I'm clicking directly on the numeric value and just dragging this. It's a real nice way to quickly edit your surface color. If you want a nice color editor, you click on the color swatch itself. That brings open your color requester. So then you can just pick your color and say OK. Or again, you can quickly drag these values and see that happening for you in the Viper window. Another option, if we have our sample sphere open here and we open our options panel, is we can set the surface sample sphere to refresh in real time. So if you see your option right here, there's a refresh rate of automatic, which is what it's set right now. So every time I drag and let go, it updates. Or real time, so that as I'm dragging, I can see interactively the settings change. So you notice as I'm dragging my color swatch here, it's automatically, or in real time rather, adjusting the sample sphere. Just keep dragging that down, and you can see how that's changing. And then, of course, once I let go, Viper updates automatically. So kind of nice. If your computer's fast enough, it'll keep right up there with you. I generally keep that on real time, or excuse me, on automatic, so that as I'm dragging my sliders around, I have real fast interactivity with the swatch. And then as soon as I let go, it updates anyway. So it's a nice, fast way to work. Other options we have here, just underneath our sample sphere, we have a sample size. So right now it's set to 1 meter. So you notice that our sample sphere here always looks the same size in this window, but the meter is going to be relative to the texture that you're working on. This is real important depending on the scale of the object that you're actually surfacing. For example, if you're creating maybe an ant, you want to be generating a texture that's very small for the body of that ant. So you wouldn't want your sample surface sphere to be 1 meter, obviously, because then the texture that looked appropriate on that sphere would look ridiculously giant on your ant object. Conversely, if you're working on a planet, you wouldn't want to be working on a 1 meter texture size because the texture would obviously be far too small for the planet. So if you're working on a planet, you might have several kilometers or several hundred kilometers or even thousands of kilometers, I suppose. And for an ant, you'd be working on the millimeter scale, so to make sure that your texture settings match the object appropriately. Okay, another option here, of course, is your preview type can be set from sphere or to cube. So once we say OK, you can see now my surface sample sphere has turned into a surface sample cube. You can also change your backdrop. So the backdrop can either be black, it can be a checkerboard, or it can be the layout's backdrop settings. So right now, you can see we've got it set for the layout background, and it's using the gradient backdrop that we have in LightWave 3D. If we set that to checkerboard, you get a nice checkerboard. I'll use the checkerboard a lot of times when I'm working with transparency, because it gives me a nice way to see through the object what's behind it. Especially when working with refraction, because then we can actually see how the refractive index is going to, that's a little strong there, how it's going to deform the image in the background. And you'll notice that also our Viper window is also showing us the refraction, which is pretty cool. We'll take a closer look at that in a little bit. Okay, let's go ahead and set this back to layout. There's also a setting for anti-aliasing. So if you've got a really fast computer, you get a nice anti-alias surface sample sphere. You can see now a very clean looking render there, although you notice it takes a little bit longer to generate. I usually leave that off, which is fine. And there's an option for use scene lights. So this way, if we just want a fast render with a single light from the top left, we can just turn that off. But if we've got a particular lighting scenario inside of layout, we want to see how that looks, you can just turn that on, and now it's going to use the lights from layout. This is real important because a lot of times the surface, of course, is going to be dramatically affected by the lighting setup in your scene. If you've got 2 or a 3-point lighting scenario, and you want to see how your specular highlights are going to be affected by those lights, you want to be able to see that on your surface sample sphere as well as on your final rendered objects. And that also applies to Viper. So when we turn these on, it's going to use the same lights that LightWave uses in the final render in that Viper window as well. Alright, there are a couple more general level things we want to take a look at in the interface. On the top right hand side, we have, of course, our surface name that's currently selected and the number of polygons that are using that. This is just an informational window that you can use at any time that you pick a new surface. You can see it's going to change the name and the number of polys. Just beneath that, we have load and save as well as rename. So if you ever need to rename a surface on the fly, of course, you just click here, type in the new name, and it's all set. Your load and save will actually save this to a surface file, but there's actually a better method for doing load and save now called the surface preset window. So you can see this window here. We're set to workspace right now, and if I choose any of these surfaces and then double click on the sample sphere here, it checks it into my surface preset. And now I can have a nice visual representation of this surface. So if at any point I want to load it onto a different surface, for example, let's say I want to replace the clouds here with this chrome, I just double click. It asks me if I want to load the settings. I say yes. And now those settings from Chrome have been transferred to clouds. So that's a nice way to work. Now you notice that inside my preset window here, it's set to unnamed. Well, if I want to name that preset, I can right click on it, and I can come down to set name, and I'll just say the name is going to be Chrome 1. And I can put a description on there. I can say simple Chrome using reflection map. Okay, this is real handy because now as I drag my mouse over the object, you notice the bottom down here updates with that information I typed in. So again, when we're working with a group of animators, and maybe you've got one person doing the texturing, or maybe you've got a group of people doing texturing, you can go through to these presets, and as you're moving your mouse over it, there can be notes about what that surface is for or how it's constructed. You might say, this surface used for all Battle Mac legs, this surface used for all Battle Mac bodies. So on a group project, very quick and easy to know, okay, this is the surface I should use on this particular model. There's another way to copy surfaces inside this tree pane here, which is a lot simpler. If you don't want to actually save it out to a preset, let's just say we want to click on our cauliflower here. I can right click on that name and say copy, come back down to my clouds, which is now Chrome, right click and paste, and it's transferred that surface data. So just for quick copies and pastes, you can do that right there contextually, but if you want to do something a little more permanent, you can check it into your sample presets over here. Now, a couple more things about the sample presets. First of all, you notice there's a little pop-up up here. And by default, it's set to workspace, which is my current workspace. So as I'm chugging along, I can just be adding things in here, sort of as a scratch disk. But if I pop this up, you see we have lots of different options. And these are libraries, surface libraries that come with LightWave Install CD. And if we pick a different one, let's just go to colors here. You can see it's got a whole bevy of different surface colors, which are kind of fun. I particularly like the names. Terra Verte, I have no idea what that is. I like tomato and wheat. So, but for more interesting surfaces, if we go here to metal, you can see that we now have some really nice looking metal presets. And this window is of course scalable, as we saw earlier, so if we want to scale this up, we can see more of those sample presets at a single time. You can scale it up to fit your entire window if you like. Again, there's some nature surfaces. You've got the underwater, the rough sea, and you simply double click, load them in. You see how you get the nice render there. There's also rock. These are also great learning building blocks. So if you're starting to learn how to do the complex texture, and you can load these up and you can pick them apart. And of course, once they're loaded, these can all be modified as well. So for example, if we come back to our, let's go up here to our metals again, and let's say we want to load in a hammered chrome. Now at any point, if I want to change the surface shading of that, the color, you can make changes to that as well. So you're not locked into just loading that preset. You can actually change that on the fly. Now, once I've got my presets loaded, let me go back to my workspace here. There's a couple more options inside this window. If I right-click, again, you can see I can just right-click on one to open it. I've also got a setting for open with parameters. This is actually not so useful in the surface presets, but more in the hypervoxels volumetrics. What this allows us to do is any attribute or any item that's using the preset that has custom parameters will open up a little panel that has a listing of the different custom parameters that you can load. In surfacing, this isn't relevant, but because the surface preset, or the preset shelf rather, is a generalized tool, that option is still there. Alright, let's take a look at a couple of the other options. Of course, we already saw the set name. There's also a move to. Let's say I'm working on this as my scratch disk, and I'm doing some tests, and I finally decide, hey, I really like this. It's a great sample setting, and I want to add it into my general library. I right-click, come down here to Move To, and I pick where I want it to be moved into. And for example, if I say metal or nature, let's drop down to metal. Now you see it's gone from here, and in my metal setting, there's my chrome. So let's go ahead and move it right back to workspace, and come back to workspace, and there it is. So you've got a nice way to manage these surfaces as you work. You can also, of course, do a copy to, if you want to leave it here in your scratch session, but also copy it to a different directory. That's a real quick way to do it. And of course, you've got your delete. Now, just under preset, that's handling all the single presets at a time. There's a library, and this is where we actually go in and manage the entire library at a single shot. So, for example, if I want to create a new library, I'll say new library, and I'll say wacky surfaces. Now I can right-click here and say move this to wacky surfaces, which will be up in our right here. So you can move things into those or copy them to that. Let's go ahead and move that over. There we go. And there you can see it. Or we can come back. Okay. And of course, there's also discard presets, which will throw away all the presets in your currently selected library. So if you decide you don't like any of the surfaces that you've moved into wacky surface, just come over here and say library, discard presets, and that'll clear everything out of there, so you've got a nice clean workspace. Generally what I'll do, instead of using the workspace here, is I'll just create a temp. So I'll say create library, and I'll say scratch like this, and then I'll be working in my scratch. Okay, and let's just go pick this here, and I'll just check these in. So you can see how easy it is just to check these in. I'm just selecting it in Viper, double-clicking here, select it in Viper, double-clicking, it checks it in. So let's say I've got several different surfaces that I've worked on that day, and I've checked the ones in that I want to keep. Then I'm all done. I want to have a nice clean workspace the next day when I get started, so I go to library, discard presets, and boom, that's all cleared out. Okay, so that's the way the surface preset shelf works. Very handy tool. Of course, if you want to close it, just click on the X key. Now, we've mentioned using these surface settings in a group environment. The surface sample files themselves are saved in the programs directory in a preset subfolder. So if you're working off of a network and everybody's accessing the same programs directory, everything should be fine. If not, you'll need to copy your presets directory from one machine to the next. Let's go ahead and take a look at where we find that. We'll go ahead and open up our Explorer here, and you'll see in our LightWave directory, under Programs, under LightWave Support, you have a presets directory. So depending on the configuration of your install, what you want to do is look to where your LightWave and Modeler executables are, and inside that directory you'll see a presets folder, and in there, of course, are all your different preset types. Under Surface Editor, you'll see colors, generic metal, there's our scratch. So basically, it's just managing these directories for you. And this way, if you want to transfer these from one machine to another, just come into that directory, select the ones you want, copy it, and of course, paste it just like you would any other file. And then the next time you access LightWave from that machine, it will have all the presets that you've copied over. There's one more generalized aspect to overall scene management of your surfaces, and that is whether you're in object edit mode or scene edit mode. And what this allows us to do is either edit surfaces per object or per the entire scene. What that means is you might load in, say, for example, a car that has a surface called car door, and then you load in another car, maybe you've got car 1 and car 2, and they both have the same surface called car door. All right? Well, in object edit mode, it's actually keeping the surface for each car separated by the object name. Okay? So if we look at our screen here, what you'll see is in object mode, each surface is embedded underneath its object name. So here we have the grid object, and under that is the cube grid surface. Okay? Under gold is the gold surface. That's because we're in object mode. So it starts off by showing the top of the hierarchy being the object name, and then underneath that is the surface itself to be edited. If we switch this to scene editing, first of all, you'll notice it comes with a requester that says, surfaces with the same name will be edited as a single surface. Do you want to proceed? And I'll say yes. And now it simply shows me my list of surfaces underneath a scene hierarchy. All right, so now it's just every surface that's in the scene just gets listed there flat. So if I had two different cars that both had the same surface name, now by editing this one surface, it would change the attributes on both cars. It's really important to be aware of this and how that functions, because you can stomp on a surface that you've been working on for some time when you change from object to scene. But it's also a nice way to have a single surface attribute that changes several different objects across a scene. For example, if you've got 100 trees in your scene, you don't want to have to go in and change the color of each tree through 100 surfaces, so you just simply go to scene edit mode, change the base of that one scene or that one tree surface, and that'll propagate across all those other objects. If you then want to go in and tweak out individual trees, you go back to object mode, and now they're separated again, and you can pick the tree that you want to change the surface of. So that's a real good way to work. Now, an important aspect to keep in mind when we're talking about surface names and object names and preset names is there are really three different things we're talking about here. Let's go ahead and take a look and make sure we're clear on that. First of all, let's go back to object edit mode, and we're going to go ahead and pick our clouds surface here. So you see I've got an object named clouds, that underneath that is a surface name called cube.clouds. All right? This is a surface name that's been assigned to the polygons that make up this object. And they're totally independent of each other. I can rename this to anything. Let's just say I want to rename that to foo.surface. All right? So it has no real relevant connection to the object name. It's just a way of structuring those. Now, if I come over here and I want to load a preset, let's just say we want to load the orange peel preset, or the Chrome 1, for example. I'll double-click on that, and it loads that on. So now this foo.surface has the same attributes as the preset surface called Chrome 1. So we're not actually changing this to Chrome 1 in the name, only taking the attributes from this surface name here and applying it to this object or this surface on the object. All right, now that we have a general feel for the lay of the land, let's go ahead and take a look at the actual specific attributes that we can change on the surface independently. Okay, let's go ahead and close our surface sample spheres here. And we'll go ahead and leave Viper hanging around. I like to use Viper a lot. And we're going to take a look at the 4 tabs here. These are our basic settings, advanced settings, environment controls, and shaders. We'll start with the basic settings here. And to get started, actually, what I want to do is I'm going to go ahead and And let me go ahead and bring back my sample sphere and load in just a default surface so we can get that reset. Alright, now what you'll notice is under Basic, we have all our standard surface controls. You've got your color, which we worked with already. You've got your luminosity. Let's go ahead and take a look at how these work. If I set my color down to, say, blue, you'll notice I've got a nicely shaded blue sphere here. Now, luminosity is essentially how much light is reflected or illuminated from each pixel. So if I set my diffuse down to 0 and my luminosity up to 100, you see this looks flat now because every pixel on the sphere is always going to be 100% the luminosity or the saturation of this color swatch. So if I increase the color, it's going to match that exactly. If I turn this back down to 0, diffusion is the amount of light basically that is going to be bounced off the surface. So if we have a light that's at 100% value hitting here, this pixel will have 100% of this blue. And then as the light fades off across the object, so will the amount of light that's reflected back. So that's just your standard diffuse settings. Specularity applies a shininess essentially. So if I crank this up here, you can see by changing the amount of specularity, it changes the intensity of the specular hotspot. Now again, we talked about earlier using scene lights. You'll notice I have a hotspot here and a hotspot here from my key and fill lights. So it's nice to be able to see your scene file settings so you can see those on the fly. Now glossiness basically changes the size of your specular hotspot. So the less glossy it is, the more matte finish you get, and it spreads that specular hotspot out. We're going to bring it all the way down to 0, so you get a nice spread out spec hotspot. If we want to raise this up to be more glossy, you can see the glossier I get, the tighter that hotspot is. Okay, and you can sort of bring these down. Now what you'll also notice is if you look up here to the top right of the interface, just off here, you'll notice that my OpenGL window is updating as well. There are a lot of basic attributes that when I'm editing them on the Surface Editor, the OpenGL window will give me just as fast a response as my Surface Sample Sphere or even Viper. It's a good idea though to use these rather than OpenGL because OpenGL is very limited on the types of things it can display. A lot of these things, even though they'll show up, they won't be as accurate as the final render. The Surface Sample Sphere and the Viper window will be very close to what you're going to get from the final render. So I really recommend using the OpenGL as a rough approximation, but of course Viper is really what you want to focus on to get the most accurate preview of that sample or that surface as you're working. Alright, so that's specularity and glossiness. Then you've got your reflection settings. And what we're going to do is turn a little bit of reflection on here, and you can see, let's bring our specularity back down. You see right now we've got some reflection going on from the environment. So it's just reflecting this background sphere basically. If we go to our environment setting here on this tab, this is where we set up what gets reflected. And you can see here my reflection options show that it's backdrop only. So right now whatever is in the LightWave backdrop is what's getting reflected off of that surface. You can see my pop-up, I've got several different options. I've got Ray Tracing plus Backdrop. With Ray Tracing and Backdrop turned on, this is actually going to reflect things that are in the scene. So for example, this object would be reflecting off of this surface here in the calculations during the Ray Trace. That does require you to activate Ray Trace reflections, which you'll find on the Render Options panel. The next Reflections option setting is Spherical Map. And this, rather than using Ray Tracing, uses an image map that you defined here. This is a real good way to fake reflections in a very fast, efficient manner. So we've got a couple already loaded. Let's go ahead and tinfoil here. And once we've got that active, let's make sure we have some reflection settings. There we go. Now if we look at our OpenGL view of this model, you'll see that if I pick it now and use my rotation tool, you've got a nice real-time reflection map. And that's that real-time reflection that I was talking about in OpenGL now. This is basically just tricking reflections by using that image map as what it's going to reflect. So if I go back to my environment here, change that to a different surface, then let's just update our reflection amount. There we go. And now you can see it's using a different image map to reflect. So just a nice quick way to fake reflections. Now the problem is you won't see these objects reflected in the other surfaces, so it won't be quite as realistic, but a lot of times a reflection map is all you need to make it look like a ray trace reflection. If you need both a spherical reflection map and the ray tracing, you can activate that here. And this way you'll get your nice real-time reflection map here. But then when you do your final ray trace render, the surface will also reflect objects from the rest of the scene. Now the reason you'll need this, we talked earlier about using the backdrop for your reflections. The backdrop is generated in LightWave, and it can either be a single color, or it can be a single flat image map, or it can be a gradient of colors. But that's basically creating a little sphere that gets wrapped around the world. And say, for example, you're working on a complex scene, but your camera is pointed in one direction. Everything behind the camera, there won't be anything there. All right, so any objects in that scene that are reflecting ray traced reflections will see everything else in that scene, but they'll also be seeing the backdrop, which will be very sparse. So a lot of times what you can do is use a reflection map along with the ray tracing to add detail to those reflections. So you can create a reflection map that looks like a cityscape, or looks like something that would approximate the back half of your set, even though it's not modeled there. Then that detail will get reflected in the object surface. So it's a nice way to add density to the overall population of the scene. All right. Let's go back to our basic surface samples, or surface settings rather. And go ahead and turn our reflection back off. And you'll notice that our next setting is transparency. And this is a real straightforward one. As you increase the transparency, obviously your object becomes more transparent. Again, this is where I mentioned earlier, having the backdrop set to checkerboard is much more useful, because now you can really see the transparency of the object. Also, a lot of times will help to have some specularity turned on. And let's turn up a little bit of glossiness. So it kind of brings out the surface there so you can see a little bit better, even when the object starts to become transparent. After transparency is your refraction index, and this is basically how strongly the surface will refract light or bend light as it goes through. So if I turn this up a little bit, you see it starts to focus or magnify the background texture behind it. And this will work with ray tracing of refraction so that you can get magnifying effects, warped effects, create water, and the stronger it gets, obviously, the more it's going to refract that back through. This is also very useful when you're working with a bump map, because as the surface gets more perturbed, it becomes much more interesting with the refraction, and we'll take a look at that in a moment. Translucency is an interesting setting. You won't see much of an effect here in the sample preview. Translucency is more appropriate when you're working with shadow casting objects. For example, if you have a character standing behind some thin paper wall that's backlit, then you would actually see that shadow from the back side. Okay, so your camera's looking here at the surface, an object in the back here would cast a shadow onto this surface, and you'll see that inverse shadow on the other side of the wall. That's translucency setting. So that's a real handy thing to have. The next setting is bump map. And bump map is not too interesting until you actually add a texture, so we're going to hold off on talking about bump maps until we explain the texture editor itself. So we'll go ahead and go down here to smoothing. And smoothing is basically a way to make rough geometry look more smooth along its contours. When you're working with polygons, you're always going to have little stepped edges to get from one point to another around a smooth surface. So smoothing will take and do a surface trick to smooth that out. Let's go ahead and take a look at an example here. If we look on screen here, right now we're working, if we go to open up, you can see our sample cube here that we're working on. If we turn off smoothing, you'll see, let me turn off specularity also so we can see a little bit better. See if I can rotate that for you a little bit. You'll notice how the edges look flat now as I rotate that around. You can see the specular highlight kicking off that sort of flat surface. Okay, that's without smoothing. If we look at this as a wireframe, which we can access right here by setting our maximum render level, we'll go down to front face wireframe. Now you can see the model file. If we take a look, it's just made up of hard edged lines. Now there's plenty of segments here that start to give it smoothness, but when we go back to our smooth shaded view, the same method there, now you can see that this is actually, those lines aren't smoothed across. Okay, so by activating smoothing, it blends those surfaces, so now you get a nice smooth edge. So you can see there, smooths right across it. Now there's another setting called the smoothing threshold. And what I'm going to do is I'm going to go ahead and go to a different view here so we can zoom in pretty tightly on this one object so you can see this. So I'm going to go ahead and change my view control to perspective. Now I can rotate the view using the view controls up here in the corner. Bring this around. So I want to zoom in a little bit. Just bring it over to this side so we've got the lighting on it. Okay, so we're going to get right in there on that cube. Now when I rotate this around, you can see the nice smooth edge. All right. Well, now we're going to go back to my surface controls here. And let me show you a quick hotkey on this. When you've got panels like these open and you don't want to actually close the panel, you just want to hide them, you can use your tab key on the keyboard, and that'll disable the panels and it'll bring them right back up as well in their same position. So rather than actually closing the window and then going back and reopening it, I'll just hide them, and then I can work on my surface or work on the object, look at it in real time, then unhide them. Now I'm going to go ahead and close Viper here so we've got a little more space to see. And what you'll notice is my smoothing here has a max smoothing angle with the smooth threshold. So as I change this, basically what's happening right now is it's saying that anything less than 90 degrees, it's set to 89.5. Okay, so anything that goes to a right angle or 90 degrees this way is going to not be smooth. So you still get that hard edge that we want to on a square. But anything that's just less than that is going to smooth across. So if the angle gets just a little bit less than 90 degrees, the nice smoothed edge. So if we go ahead and take a look at changing this value here, you get a little spinner. I can change that. And notice as I get lower, more angles start to smooth. So you can see the polygons as you get to different degrees, well, the angles smooth right out. Okay, this is actually very handy. Generally, what you want to keep at is that 89.5 default. But sometimes if you want something to smooth out that's even actually a little more square, you can crank it up over 90 degrees. Or if you want some areas to be rigid and flat while other areas are still smooth. So for example here, we can keep the front face kind of flat and then some of the edges a little bit more smooth. Then we can see our model how that changes there. Now we've got flat mixed with smooth on that one surface. So the smoothing threshold allows you to change that on the fly. Again, most appropriate is at that 89.5, so we'll just reset that there. The final basic setting here is double-sided, and basically when you create a polygon, there's a single side to it. There's what's called a surface normal. So I'm going to go ahead and show you how to build the basic building structure of a polygon, which is covered in the modeler tapes. But I want to show you that so you can see where the surface normal is defined and how that affects the surface settings. So we're going to go ahead and switch over here to modeler, and I'm just going to make a simple box flat this way. Okay, and now you can see in my perspective view, let's just go ahead and change our surface here. Okay, we're just going to make a nice blue polygon there. So you can see in our perspective view, from this side, get out of the grid there. From this side, you've got a nice solid polygon. Now from the other side, you'll notice that as I flip it around, there's nothing there. It's like magic. All right, well that's because this is a single-sided surface polygon. So if I go ahead and pick the polygon, you see this little line drawing out of it? That's the surface normal that tells us which way that polygon is facing. I can flip that, and now it's facing the other way, and you notice that the polygon is visible from the other side. All right, most of the time you won't need to worry about this because your polygons are facing the right direction. If by some odd chance your polygons are inside out, you might want to either come into Modeler and flip the polygon, or on your surface settings, so down here on the bottom of our basic settings is double-sided. When we activate this, now even though the normal is facing out this direction, it's going to draw the surface on both sides. So it's basically just mirroring the surface from the normal or along the normal, so that regardless of which direction my normal is facing, I'll see that polygon from either side. Now you might think, hey, I'll just leave double-sided on all the time and then I'll have to worry about it. Well, the problem is double-sided is kind of a trick, and it can cause some problems when doing ray tracing because rays will get confused as they're trying to move through a double-sided surface. There are also other times where you don't want the double-sided surface because when your object turns around, you don't want it to be visible from that angle. So I recommend don't turn that on by default, but in a pinch, you can go ahead and activate that if your polygons are flipped or you've got something that's imported from another program and you don't want to have to deal with going in and flipping each individual polygon. This is a quick way to fix that. Those of you following along may be a little confused because I was in layout here using the surface editor, and now I'm in modeler here using the same exact surface editor. So what gives? Well, we've got the same surface editor controls because the two applications are linked via the hub, which means if I just go ahead and come up here to my current item pop-up, I can choose any of the objects that are currently in layout. So if I want to go over here and say, let's pick the, let's go with orange. You see here I've got that orange object that I have over in the other environment. But if I come to my surface panel and edit the orange surface, let's just make it more yellow. Now when I come back over here and go back to my camera view, you'll see my orange peel surface is now set to yellow as well. So it's sharing the data back and forth. Therefore, we want to have the same exact surface edit controls in both environments. So as we're working on a model here, or changing the geometry, it's getting updated in both environments. So you really don't have to think of it as two different applications. Think of it as two different editing environments. So you're working on your model or your animation, and you want to change something about the model. You can simply click on Modeler, and it'll bring Modeler to front with that object enabled. Then you can make your changes, whether it's geometry changes or surface level changes. And when you come back to your animation, those changes are already there. Let's go ahead and take a look, continue working in the modeler here. One thing I should point out, because modeler doesn't have a renderer, you won't be able to use Viper inside this window because it needs to trap that render data that it gets from layout. So for working with Viper, you do need to be in the layout environment. Alright, let's go ahead and jump back over to layout then, so we've got that environment set. And let's take a look at some of the advanced settings on our surface panel here. So come to the Advanced tab, and the first thing we'll see is called Alpha Channel, and it gives you an option for the Alpha Channel setting. First of all, let me explain what Alpha Channel is, and to do that we're going to make a quick render. We're going to go down to my camera panel here, and since I'm going to make a render, I don't need to have anti-aliasing on, so I'm just going to turn off anti-aliasing. I'll go ahead and leave it at full medium res or 100%, 640 by 480. That should still render pretty quickly. But under the render options over here, I want to make sure that I have my render display set to image viewer. This way when it's finished rendering, it'll show me the final rendered image. If I want to, I can also turn on show rendering in progress, and we'll go ahead and leave Viper on. It's just telling me that show rendering in progress takes a little bit longer. That's okay. It's not too big of a deal. So to make a render, I'm going to use my F9 key on my keyboard. That makes a test render. And right now I've got, there it goes, boom, a scant 4 seconds. Not too bad. And what you can see here is I've got the final render of the scene, but if I look at the top view here, it shows that I'm looking at the image. I can also tell it to look at the alpha channel. And now you can see a nice alpha channel version where the white pixels are areas that are opaque, the black pixels are areas that are transparent, or where there's no geometry. You can see here on an object that was semi-transparent in certain areas, you've got some gray areas as well. Again, let's look at the image there. You can see how we have kind of a glass surface in here that you can see through to the background. And then this where you can see absolutely through to the background. When you look at the alpha channel, you notice that there are some black holes in this object and some gray to black areas in this object. So that's how an alpha channel is used for compositing in different programs. Now in regards to the surface settings, let's go back to our surface editor here. And under Advanced, alright, let's go ahead and open up Viper again. And let's take a look at, well, let's go ahead and take a look at this object right here in the top left corner. So I'm going to click on that, and what do you know, that was brushed metal. Very good, so it selected that for me. I'll go to my Advanced tab, and rather than using surface opacity, I'm going to change that to constant value. Now remember, surface opacity was based on basically how opaque that surface was, right? So anywhere that it was transparent, you get less of an alpha channel. Anywhere it goes to opaque, you get more of an alpha channel. It's pretty straightforward. So let's go ahead and go change this to a constant value. So in case you need to have an object that's always filled into the alpha channel, at 255, that will always be 100% opaque. If I set this down to, say, 128, now we make a render, and what we'll see is our alpha channel comes up, and it shows us that this is now half between the black and the white. So it's at that 128 degree, so half of the step there. Again, there's our main object and our alpha channel that gets filled in with that surface setting. Alright, the next one is unaffected by surface, And this way we can have objects that don't fill into the alpha channel. So what you'll see is when I render here, and then it comes up, you'll notice that it's missing from the alpha channel altogether. All right, that makes sense. It's unaffected by surface. And this is important for some compositors. If you don't want to use the alpha channel or you don't want that object to show up, you can just subtract it straight from the alpha channel there. This is also good for doing what we call shadow pass objects. All right, and finally, we have the shadow density. And this is basically going to look at the surface and see where there are ray trace shadows, and then where those shadows are darker, it's actually going to add more into the alpha channel. The reason for this is if we wanted to do a composite where we've got a character or something standing on a photographed table, we want to put in a table polygon that represents the surface of the tabletop. We don't want that polygon to be put into the alpha channel, but we do want the shadows that the object standing on top of it casts to be added into that alpha channel. So now what you would get is you'd get the character, its alpha channel, and the shadows from that character added into the alpha channel. So it's also a nice way to do compositing. All right, let's go ahead and set this back to our surface opacity, the default setting. And the next setting here is special buffers. And what this does, this works alongside of image processors that use the special buffers flag. The purpose for this is so that certain image processors can actually take advantage of a surface setting. So for example, if we're using an image processor like a blur, you can have that the creator of the image process blur could tell it to respect the special buffers. If they do that, then in your special buffers requester, when you click on that, it'll come up and it'll say blur, and it'll have a value. And that value can be anywhere from 0 to 255. If you set it to 0, that object will not be blurred at the final image process. If you set it to 255, it will be 100% blurred. If you set it to 128, it'll get half of the blur value. And that can work with any type of image process as long as it is programmed to handle special buffers. So it's just a nice way for surfaces to be flagged specifically for post-process. The next thing is our glow intensity, and this works along with our image post-process called glow. So this way we can have a glow set to a particular surface, and we can vary that amount that it's glowed. So if I set this up to 100%, it will receive 100% of the glow value at the final render. If I set it to 50 or 72, it'll receive that percentage of the glow at the final render as well. All right, so let's go ahead and take a look at how that works. First of all, once we've got our glow intensity set, we'll just set that to 100%. Now over here on our Scene tab, there's an option for Image Process down here at the very bottom. Okay, we open that up, and now at the top here you'll see Enable Glow. All right, so if I turn this on, now it's got a glow intensity and a glow radius. These are global settings, so if I just activate this, any surface that's set to use glow will get the intensity of 50% and a glow boundary of 8 pixels. All right, now having the glow intensity also set on the surface will modulate the percentage that I have set on the global setting. So for example, let's go back here and say, go ahead and turn up our intensity to 100%, and let's set our glow radius to 20 pixels. All right, and we'll go ahead and just leave that open there. Again, I've got my glow intensity here set at 100%. So we make a render. See, it renders the polygons, and then it'll do the post-process glow. There we go. And now you can see that's 100% of our glow amount. So let's back to image. You can see our nice glowing halo around that object. Let's go ahead and set another object. How about cauliflower? Let's set this one also to 100%. We'll go back to our brush metal and set it to 50%. Now we'll make our render. And this time, of course, cauliflower will get that 100% glow halo, but the brush metal will only get 50% of that. So we can see, if we take a look at our final render, this one gets a nice bright glow of 100%, and this one is now muted down to 50%. And these can be animated, but it just gives you a way to have a glow applied to the entire image, but to vary the amount of the glow on a per surface basis. And again, because you can envelope those glow settings, you can actually animate that over time so you get things to sort of pulsate or flicker or whatever you like. Okay, one more thing about the glow here. Basically how it functions is it reads the pixel value on the edge of the surface, and then it uses that to base the intensity. So if you've got sort of a whitish pixel here along the edge, it's going to smear that out to be white. So it's not really reading the lighting of the surface, it's just reading the actual luminosity or brightness value of the edging, and then adding that and stamping brushes down to create the glow around the outside edge. Alright, let's go ahead and close that down. The next thing, of course, is render outlines. This is a pretty straightforward one. We'll go ahead and disable glow, and let's get rid of that panel. We don't need it. And we'll turn on brush metal, we'll turn on render outlines, and you can see immediately it's actually going to show our object to us in the wireframe view. Now the cool thing about this is when we render it, not only will we render it in wireframe, but it'll actually take the surface attributes from that original surface. So you've got a wireframe that's textured with that cool brush metal look. So that's basically what render outlines does. It's pretty straightforward. The next thing is color highlights. And to show this off, I'm going to change my surface a little bit, and I'm going to go ahead and open up Viper again. And actually what I'm going to do now is I'm going to go ahead and create a new camera here. To do that, I'm going to go to Items, Add, Camera. And we'll call this Close-Ups. Okay, so I've got my Close-Ups camera. I'll move this over, and this way I can just zoom right in on one screen. The reason I like to add another camera is that a lot of times I've got an animation where I've got camera motion, but then for tweaking surfaces, I want to be able to do a close render of a particular object for incorporating into Viper. Well, rather than moving my camera that I've already got animated, I just create a new camera, a generic camera, put it in that position, and then I can render it without worrying about screwing up my original animation. So we've got our object or our camera set there. Let's go ahead and rotate our object around a little bit. And then we go to render here, and we get the render of the nice tight close-up. Again, it records the Viper data. And there we go. Perfect. And we render, you can see, huzzah, our nice big Viper preview of that object. First thing I want to do is go ahead and get rid of this overall surface. So instead of mucking about with all the surface settings, I'll just bring up my surface presets here, and I'll go back to my workspace, and I've got a nice default smooth here, so I'll just load that up, and that gives me my nice default smooth surface. What we're going to do for color highlights, I need to go ahead and add some specularity because color highlights work directly with specularity. So first of all, let's go ahead and change our color back to a nice deep blue, and crank up the specularity there, and reduce the glossiness so it kind of spreads out along that edge. That's pretty good. Now you'll notice that the color highlight right now, or excuse me, the specular highlight is mostly completely white. If I come to my advanced here, under color highlights, if I crank this up to 100%, my specular highlight tilts towards that blue. Now I can fade that in, so I can make it sort of halfway between white or blue, or all the way to that blue shade. So that's what color highlights does. It basically takes the base color and applies it into the specular reflection. So you can see again on the sample sphere it's even clearer to see the very white hot spot versus the colorized hot spot. Color filter and additive transparency both work in conjunction with the transparency controls, the basic settings of the surface attribute. Color filter basically takes any of the surface attributes and passes that along to the surfaces behind that transparent object. That also takes into account shadows. So for something like stained glass window, you've got light shining through the stained glass window. You'd want to have color filter turned on so that the light picks up those surface colors as it passes through to the surface behind. Additive transparency is especially useful if you're faking volumetric lights. So you've got a surface that's semi-transparent and another surface that's semi-transparent. If they are layered in front of each other, rather than just seeing one behind the other, it'll add the two together, giving you a brighter hot spot, as in the case of two volumetric lights crossing over each other. Finally, diffuse sharpness is a setting that changes the fall off of the diffuse setting. So let's go ahead and come back to our surface samples here, and we'll go back to our default white, and back to advanced. And you see there's sort of a fall off here that happens. It's actually easier to see on the sphere. Nice smooth fall off on the diffuse shading. Well, if I change this or crank this up, you see it makes it a tighter fall off. All right? This is actually very appropriate for doing planets, because in something very large like a planet, the diffuse fall off from the sun is a very hard edge. So if we come here, let's go ahead and turn off use scene lights. In this case, we don't want to see both lights. So now you can see you get a hard fall off on the diffuse terminator. If we crank it up to 100%, you get almost a complete edge. So if you're doing something like planet Earth or a moon, this is the kind of setting you want. If you're doing smaller scale objects, you get a more smooth fall off on the light as it goes across the surface. The next tab is the Environment tab, and we already took a look at the reflection options. The next one down beneath that is refraction options, and this is a cool feature that allows you to fake refractivity. Again, this works with our basic transparency settings. So if we have some transparency set on, you see here, but if I go back to my environment under refraction options, if I set this to use a spherical map, for example, now it's going to change the refraction index. I need to turn up a little refraction index here. There we go. Now that we've got that, it's actually using that tinfoil map to create a refraction index. Alright, so it's faking refraction using the image. So it's a quick way to modify your refraction settings based on an image that's set in the environment settings. And again, this can be any of the same settings that reflection uses between ray tracing and backdrop, a spherical map, or the backdrop only. And finally, the last setting, let's go ahead and set this back to not transparent, is the Shaders tab. And this is where we get plug-in shaders that can do all kinds of cool things to the surface. For example, if we want to do things like thin film, you can open that, and by double-clicking on it, that's how we open up the interface. So if you want to change the color that's going to shade through, and again, you can see how Viper is updating, this window is updating. Thin film's pretty cool. It's basically using the incidence angle to the camera, or the angle from the camera to the polygon, to determine what color it is. So if I click right on green, it's going to be green edge on or face on, and then it's going to tilt away from green as it goes out to the edge. If I change my angle variation, let's just set that up to like 180. So it's now going to go from green 180 degrees through hue over to red as it falls off along the edge. There's lots of different shaders. You can experiment with these. There's cell shader for creating cartoon style render. If we want to access the interface, again, you double click here, and that'll bring up your interfaces. If you want to leave this in the settings but disable it, you just click your little on checkbox, so now you can see what it looks without the shader, and then with the shader, you just turn that off and on. Go ahead and remove the shader by clicking here. Other shaders, there's a real Fresnel. Fresnel effect is pretty interesting. What that does, it's also similar to thin film, where thin film was changing the color based on incidence angle. Well, Fresnel changes transparency and reflection attributes of the surface based on the incidence angle to the camera. So for example, if you're looking at a glass window on a store, you'll notice that if you get edge on to that glass, you'll see more reflection than you do if you look straight at it. Okay? Same thing happens if you're watching television. You'll notice if you get a light shining right above your TV, you get a really nasty glare as opposed to the light that's shining from over here. That's because the angle of incidence from that light to the screen determines how reflective that screen's going to be. So that's a real physical property of reflections and transparencies that you can reproduce in LightWave by using that real Fresnel setting. But that's generically how you control these plugins. You can add them from the script, from the listing here. Again, you can access their interface by double-clicking. Some of the interfaces that are designed for being in the we call the grazer will actually put their interface right down here. Others that are too large for that, for example, Supercell Shader, it's going to bring its own panel up. And again, to access those, you simply double-click, and then once you've got those set, you can make your changes interactively, just like any other shader attribute. Okay, now that we've covered the basics of the main surface control panel, let's go ahead and take a look now at the texture editor and enveloping or animating our surface parameters. Okay, what I'm going to do is we're going to go ahead and change scenes here. I've had about enough of the texture examples. So go into your General Options, Content directory, and under Features, there's a directory called Volumetrics. Let's go ahead and go in there. And although we're not using volumetrics in this case, there's a nice little scene that I like to use here. So go to Load Scene and use Primitives No Ground Fog. And this is just a nice little scene that has a few shapes that we can use for texturing. Alright, make sure under your render options that you have Viper enabled. There it is. And then let's go into our camera's properties. So camera, properties, and let's turn off anti-aliasing here. And make a render. Hopefully your computer is as fast as mine, and we'll have it in lickety-split. That's right, I said lickety-split. All right, so there's our render. Again, we're going to go to our surface editor, which we can find up here under Actions, Surface Editor. And now you can see we have our render. Again, our backdrop is set to checkerboard. That looks a little funny. So under our Options, we'll set that back to Layout, and we'll tell it to use Scene Lights. Make sure that's all set. There we go. And we're all good. Okay. Let's go ahead and get back to our Basics tab here. And now you can see that next to all of our surface attributes that we just reviewed, there's an E button and a T button. E stands for envelopes. T is for textures. And textures can be a number of different things. They can be they can be texture maps or image maps. They can be procedural textures, or they can be gradient ramps. And gradient ramps are a fairly new technology that we've added into LightWave that allows us to change surface attributes based on different input parameters. For example, the light incidence or camera incidence or distance to another object, or even things like bump height or slope. So we'll get into that here in just a minute. Let's go ahead and talk about surface envelopes to begin with. So we're going to go ahead and let's go ahead and pick the round sphere here by clicking on it in Viper. Okay, so that picks our ball surface. And what I want to do is I want to make a color envelope for this surface. So to do that, again, we click on the E button, and that brings up our graph editor. The graph editor is, of course, the generalized tool for animating different values, and typically you would associate this with animating the motions of an item or rotation. But in this case, because we've chosen a color envelope, you see we get ball color R, ball color G, and ball color B in here as a triplet, and that's all selected. And you can see here, right now the surface color is red, and you'll notice that that's visible by seeing this little red bar on the bottom. Now if we want to create new keys, as we know from the graph editor, there's a little create key button here. So we'll click on that. And now let's just create a couple keys, maybe frame 10, 20, 30, 40, 50, and we'll zoom in a little bit and say 60. Alright, so right now I've got them all at gray. So what I'm going to do here is I can modify these keys by clicking the Move tool, and then if I click on a keyframe and drag it, you can see I'm dragging the red channel, and you can tell that because red is the color of the line there. Or I can grab the blue channel, drag it around, and you'll notice that my color swatch down here updates for me in real time, so I can see exactly what color I'm going to get by mixing these together. So this is how we can mix the R, G, and B to change the colors over time. Now, if I don't want to have to try and figure out what colors I have to mix to get yellow, what I could do is right-click on any of these keyframes. See here how it lights up as I drag over it? Let's just go ahead and click on one of those, and that brings up our friendly old color requester. So let's say we want green there, and that sets the triplet. Let's zoom out a little bit. That sets the triplet to the appropriate values to give us that color of green. We can go in here, and we'll say we want to go to a nice blue, and we'll say yellow. Just get some wacky colors here. Try orange, maybe a nice purple, and then let's just do one that's just straight out white. Okay, so you can see how by clicking on those little color wheels we get the color requester, and then picking that's going to give us a nice color indicator here. Now the nice thing is, again, if I use my tab key on my keyboard, that's going to hide those panels for me. And you can see now if I drag my slider, I can see that animated in OpenGL, so I can see exactly what the color is going to look like in my animation. Another thing I can do, if we go tab here again, is we can show that animation inside of Viper, but I'm going to wait until we get something a little more interesting before we do that. So you can see the color enveloping is very powerful. Of course, because we're using the general enveloping tool, the graph editor, any of the graph editor's functions for changing the contour of the curve or having the end behavior be repeat or offset and repeat, all those things can be applied to those color envelopes because it fits right into our generalized channel editor. Now for things like diffuse or luminosity or specularity, those are single values, so you would animate those exactly like you do any other single curve. So it's pretty useful to be able to have that graph editor, the same graph editor used for all other animation in LightWave, to control all of your surface attributes as well. Another nice side benefit of that is because these are just straight channels, these channels can be linked to other channels through expressions or through channel follower or other tools inside of LightWave. So you want to do some experimentation, you can do cool things like have the color of an arm change based on the rotation of a bone. If you want to have a bump map height increase as the skin wrinkles out, you can do that by attaching the bump map height to the rotation of the bone as well. So you can do all kinds of neat things. Or you can attach bump to a morph target, for example. Some real good advantages to having that generalized graph editor there. Now let's go ahead and take a look at some of the texture editing tools. And we'll see we have a very powerful set of tools there as well. Let's go ahead and use this base color. We'll leave that so we've got the nice animated color for the base. And I'm going to click on the T button for texture. Alright, now the first thing you'll notice is it comes up. Basically we've got sort of two windows here. One, which is your layer repository. Right now we only have one layer. This is where we can add lots of texture layers if we like to, and you do that right here with your add layer. You can choose what type of layer you want to add. Of course, if you want to remove a layer, you've got the remove layer next to that. Then you've also got your copying and pasting layers here. And this is nice because not only can you copy a single layer, but if you have several layers, you can copy all layers. This way, if you have a nice texture that you've added to one surface and you just want to copy that from the color channel to the diffuse channel, maybe it's comprised of 7 different layers, you can copy all the layers at one shot and then paste by replacing the current layer or replacing all layers or adding, appending to the layers as well. It's a great way to copy and paste or move those layers around. On the right hand side we have our layer type. In this case we're using an image map. You can also choose from a procedural texture or a gradient ramp. Right now we're just going to go ahead and use a procedural texture. So procedural texture adds on. You can see it immediately in my Viper window there. You've got the turbulence that's starting to appear on my surface. What we'll also see is this window being updated. Let's go ahead and change the color of that turbulence. Do that exactly the same way we use the other color widgets by simply clicking and dragging. And you can see that's added sort of a blue. Of course, you've also got the ability to change your layer opacity here. And this is the strength at which this layer is added to this surface. So if we just turn this down to say 50%, you see now it's half as opaque on that surface as opposed to dragging it back up to 100. There's several generalized tools for the fractal noise settings. The frequencies is the number of fractal patterns that are displaced in the surface. If I add more, it'll become more complex. If I add fewer, you see the pattern in my little 2D window changes there, so you get less noise in that fractal pattern. Contrast is pretty much exactly what you'd think. It's just going to change the contrast of the surface. And small power adds a small fractal noise inside of that. So if you crank that up a little bit, so you get a bit more of a pattern inside there. Now one thing you might notice right now is that this sphere here looks significantly different from this one on the screen here. The reason for that is this sphere itself, let's take a look at how big it is. If we go to our top view here, just by setting this like that, and let's go ahead and set this to wireframe. You can see that my grid square size is set to 1 meter. So if we look here, let's zoom in a little bit using my greater than key. You'll see that this sphere is actually 1, 2, 3, 4 meters across. Alright? So remember we talked about our options. What I can do is set this to a 4-meter cube, and now you see it's starting to match much more accurately. The reason you see a little bit of difference, the texture size looks about the same. The texture is a little different because this is oriented to the camera a little differently than this. It looks like the same object, of course, because it's a sphere, but this is just a generalized sphere object, whereas this is a real-world sphere object in world space. So sometimes the texture shape will be a little different, but the size and position should be about the same. Alright, now if we want to change our procedural type, you find that right here, and you'll notice that there are a ton of procedurals built into LightWave. These are really interesting surfaces. A lot of them are pretty straightforward. Brick, things like honeycomb, it's going to look like a honeycomb. You know, bricks are going to look like bricks. Checkerboard is going to look like a checkerboard. Some of the other ones are a little more esoteric, like crumple or crust or even FBM. These are just different fractal patterns. But a real good way to learn sort of what these different patterns are going to look like is to open up your preset shelf. And in there is a work group called Textures. And all this is a straightforward look at each individual texture that is loaded into LightWave 3D. So all those procedural textures, there's your turbulence noise, multifractal. You notice those match exactly to the names here. Multifractal, turbulence noise, puffy clouds. So you can see puffy clouds on the surface down here. Okay, so it gives you a real quick and easy way to go and sort of examine what the different procedurals are without having to go through and set them up yourself. And of course, if you want to add one of those, you can just double click that to bring it in. Okay, other settings that we have here. Say once we pick a surface, let's go back up to turbulence here. Now we can do an automatic sizing, which will try and scale the texture to fit the bounding region, which in this case is 4 meters because we have a 4-meter sphere. Or I can change these with my little spinners. Let's say we want it to reduce the size dramatically here. You just see by dragging those around, you get some feedback. There's also a position, so you can change the position of the texture. In this case, because it's a fractal pattern, position isn't going to matter much unless you want to animate that position. So let's go ahead and do that. This is pretty interesting stuff now. So what I'm going to do here is we'll go ahead and animate on the z-axis. What you need to think about these textures is that they are truly three-dimensional. A lot of times when you're looking at a surface, it's easy to visualize that texture as paint on the outside of the surface, but it's actually a three-dimensional texture that can be moved through a volume. And we can exhibit that by animating that through the z-axis. So if you think about you're seeing right now, this sort of smoky or fractal pattern you're seeing is actually extruded back through space in a fractal pattern as well. So as I push it through on the z-axis, the surface is going to sort of boil along. So let's go ahead and do that here. So go to our z-axis to envelope or animate it. Again, simply click on the E button here, and we'll bring our graph editor to front. And you can see that it's already got my texture layer position z-axis chosen for me. And we'll just add a keyframe here. Let's zoom in. We'll hit the A key, which will auto-fit just like it does in Modeler. And it's traveling 3 meters. That's a little far, so we'll go ahead and set that down to about 1 meter. And we'll close that up. Now, typically, we'd think about doing our previews in OpenGL, right? So if I hit the Tab key here to hide those windows and set this back to solid shaded. But as I mentioned earlier, we can't see procedurals. So there are some things that OpenGL is just not going to show us. So it really doesn't give us a very good indication of what our surface is going to look like. Well, if I hit the Tab key again and bring back my panels, this is where Viper really starts to shine. What I can do is I can come in here and I can say Make Preview and say Go, and you can see now it's actually animating the color and it's animating that procedural texture that's mapped on the sphere as well. Go ahead and let it animate a little bit further. If at any time you want to stop it, you simply hit the Escape key, but we're only about 4 frames away, so I'll let it go. Now we can just hit Play Preview, and you can see the color animating as well as that texture kind of boiling in behind it. Now the color animation there is a little distracting, so why don't we go ahead and make one more preview without the color animation so that we can see just the animation of the texture. So to do that, we'll go back to our surface editor, hit Use Texture, go to the envelope here, and to disable the envelope, all I have to do is hold down the Shift key and click on E. That removes it. Let's go ahead and set this to be a darker shade so you can see that nicely on top there. A little darker even. And now we'll say Preview. And we'll let that generate. Again, notice that Viper's only updating the area that needs to be. So it's graying out the other zones so we don't have to worry about it drawing extra data. This is a great way to test the speed of your texture or the direction of the texture as well. Looks like this one's going to be fairly subtle. There you can see it kind of boiling through as it moves through Z space on the object. Alright, I'm going to go ahead and change that texture size a little bit, but while I do that I'm going to explain something about traversing numeric fields in LightWave. One thing we know is that a lot of times, especially in this case, you've got a triplet that you need to modify. So the traditional standard would be to use the Tab key to move through the fields and then the Enter key to dismiss it. What we've done is we've actually got a little bit different scenario where we know that you use the numeric keypad very quickly to traverse those 3 fields. So if I just want to say 0.5, 0.5, 0.5, I can do that very quickly as opposed to using 2 hands to 0.5 tab, 0.5 tab, 0.5 tab. Now, if we want to just do a single value, we would use the enter key. So for that I would say point 2, enter, that submits that value and checks out of those fields. Okay? This is real important when dealing with fields like this. But if we go to our main screen here, you can see a value like this where I'm setting all these fields. You may not want to have to sit in here and hit enter, 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 enter like this. So instead, you could go through, set your value, and when you're done, hit the return key. That sets the value and checks out. So essentially what we're getting at is that the enter and the tab keys work very similarly, the numeric enter key and the tab key, so that we can, when we're traversing fields with numeric values, we can do that very quickly. All right, let's go back into the texture editor. Now what I want to do is show you adding different texture types. So we're going to go up here to the top of our window, and you can see there's an add layer button. So we're going to add a layer, and we'll call this one a gradient ramp. And you can see immediately the white gradient here is encompass the entire surface. All right, so that's just painted right on top of it with this pure white gradient. Now the gradient input parameter, this is a real important thing, is set to previous layer right now. So since the previous layer is this procedural texture, it's going to use the grayscale values to ramp this gradient through. So in other words, if I put a key down here and we make that key red, anywhere that the surface before it was absolute, it goes to red. Anywhere where it was missing is going to go to white. So what I'm doing here is just disabling the layer so we can see it before and then after the gradient. Now that's not so interesting because you think, well, I could have just changed the base color. But the neat thing is I can go in here and add more keyframes like this. Let's just add a really strange color here in the middle. And now I can change the way these go through there. So you can completely change the look of your surface. If you want to choose a color this way, do that. And again, just drag these around. And you can see how that's going to feed in through that procedural texture. You can get some really interesting effects. Now another thing I can use my input parameter for is to change towards things like bump. So if I have a bump map, that'll be applied through the height of the bump. Or slope, which is basically the axis to the world. So you can see here at the top of the slope, it's going to be white, falling down to yellow, falling down to blue, and then at 90-degree axis, it'll be red down to the bottom this way. Again, changing your keys here. We can change the way that that follows through to create all kinds of interesting effects. Incidence angle. This is based on the direction that the normal of the surface faces the camera. So when it's edge on, 90 degrees, this is facing directly to the camera, or falling off to the edge here, which is that 0 at white. So again, some interesting things there. You can also do incidence angle to a light, and you have to pick your light. So light 1 you can see is obviously shining from up on this direction, and light 2 shining from over on this direction. And if you move your lights, of course, that's going to move the incidence angle along with it, so it's a cool way to animate that. You can create some really nice effects that way. And again, you can do distance to camera or distance to object. You can do a single axis distance, X, Y, or Z, or you can use a weight map, and we're not going to go into that. If you've seen the modeler tapes, that explains the weight maps, but that's a little more advanced function. Suffice it to say that the weight map that's assigned in modeler will apply values to individual points, and then the gradient can read those values and feed the colors into it. Okay, so these are pretty interesting on color. I'm going to go ahead and leave this on previous layer there to get a real interesting looking surface. Next thing I want to do is go ahead and copy that procedural texture from this layer to a different channel. So to do that, I'll simply go up here, choose the procedural, tell it to copy the current layer, not all layers, because I only want the procedural. Say use texture, and now I want to paste that onto transparency. So go to transparency, texture, paste, and we want it to replace the current layer. And you notice nothing happened because what you see is the texture value right now is set to 0. Because it came from a different type of setting where before it was color, now it's going into percentage, it just defaults to 0. So I need to go ahead and crank that up, set that to 100%. Now you can see anywhere the texture was bright becomes transparent, and anywhere it was dark becomes opaque. Now here's an interesting point about Viper and transparencies. In the previous renders where we had the texture examples, there was no geometry behind the objects, and so we could see the background perfectly. Well, now you'll notice that rather than seeing the checkerboard through here, you're actually seeing that backdrop gray. This is because when we use Viper, Viper doesn't actually know about the geometry. It only has extra information about 2D, about those 2D pixels. So the pixels in the front here don't know anything about the polygon behind it. So when you set transparency, it's really just setting an alpha channel on that pixel, which is showing then the background behind it. So if you want to see how that is going to affect the transparency, the best thing to do is set your backdrop to checkerboard, as we did earlier. So we come back here to Options, set our backdrop to checkerboard, and now you can see the checkerboard through there, so we can see exactly how it's going to be affected. All right, what I want to do now is I want to take a little closer look at this. So as I did earlier, I'm going to create a new camera. So I'm going to go to Items, Add Camera, and again we'll call this Close-Ups. And we'll go ahead and go to our camera view. And let's go ahead and move our camera around a little bit here. Okay, very good. Perfect. Again, we'll make a quick render. And we do this so that the Viper window can trap that information. So there you can see our surface. Kind of a cool looking surface we've got there. And we'll go back to Surface Editor here. And we see now we've got the surface sample sphere with that checkerboard in the background. Now if we go to Use Texture here, you can see our refraction index. We've got some transparency. If we increase our refraction index, you can see now I'm actually seeing the effect of refraction through that sphere on our Viper window. Now another cool thing I can do with this, let's go back down to our bump map here, and we'll hit Texture for bump map. And I'm going to go ahead and paste that same layer onto here. All right, and that'll give me a little bit of bump if we crank up our intensity a little bit. So now you can see by roughing up that surface, you see the transparency and the refraction working together to give a really interesting looking shape there. Now the nice thing is, again, I can go ahead and generate a preview, and now that texture that's animating, because I copied it from one surface to the next, I had an envelope on the first channel, which was the color channel, pushing that texture through the z-axis. By copying that and pasting it on transparency, copying it and pasting it down to bump, now I've got the same animated procedural texture running through all those different channels. And with Viper, of course, because I'm using the Viper window showing refraction, I can actually see then how the ray trace refractions are going to affect that backdrop in the final render. So let's go ahead and now take a look at these frames. Just got a few frames here. Okay, to get out of it, we'll just hit the Escape key, and we'll say Play Preview. And now you can see the refraction, the boiling texture, everything happening in real time just by generating that preview. So it's much faster than actually having to re-render everything, because we can render just the portion of the scene that we're trying to look at. And you see you can create some really wacky effects this way. Lots of detail can be added to a surface very, very quickly. And again, with the preset shelf, you can really learn a lot about how to mix and match these textures. Okay, so now you've seen copying and pasting of texture layers. I kind of threw a curve at you there by just jumping right into bump mapping. So let me go ahead and explain a little bit about bump mapping and the fundamentals and how we apply that. Let's go ahead and jump back into here to our surface controls. And I'm just going to go ahead and remove all my textures here. Let's go ahead and remove the transparency. Just like I used the Shift key to remove my envelope, if I hold the Shift key down here and then click on the T buttons, that removes my transparency. Then I go up here to my next T button, click on that, and that removes the color. And now I'm just left with this nice sort of cobalt blue sphere. Let's go ahead and give it a little bit more shade there. Just crank up the blue a little bit. All right. So right now you'll see the surface is very smooth. This is very, what we say, CG, very computer graphics looking. And we want to rough that up a little bit. So we want to perturb that. Without adding geometry, what we have to do is use what's called a bump map. And bump map down here, we can see, doesn't have any real effect if I just change the value on the outside here, because it relies entirely on a texture inside, a bump texture. So we're going to go ahead into T button here. So one of the great things about the architecture of LightWave is that there are a lot of generalized tools. For example, Viper you'll find in many different places in the application, not just on surfaces. The texture editor, you'll find that in many different places. So as I'm editing a texture on transparency, it'll be the same texture editor that I use on the bump channel, which is also the same texture editor I might use on a volumetric light. So once you're familiar with the generalized texture editor, you're all set all the way throughout the app for any kind of texture editing. So in this case, we're going to go ahead and change our layer type to procedural. And immediately you'll see a little bit of change to the surface here, how the specular highlight has changed a little bit. Right now my texture size is a little too big, so we're going to turn that down a little bit. and now you see it really starting to rough up the surface. There are very few things in the real world that don't have some sort of perturbation on it, or some little dents or dings. And so when you see things that are really smooth, it kind of gives away the fact that it's computer graphics. By adding this bump map, we start to add the noise that's required to make it look more photorealistic. And again, we can crank up our texture value here, which will increase the bump height a little bit. I can go to my procedural type, say let's go to move to dots. Then what I'll do is give a little bit of fuzzy edge width, so it has something to bump it with. Now you can see it adding little bumps here. Let's go ahead and make it a little bit wider. Maybe increase the size a little bit. So you can see those little bumps jumping in there. Let's just change this to, say, let's go with crust. So you get some really interesting crusty shapes looking there. Or we can go to crumple, which really does a nice job of modeling up that surface. So you get the idea here how with a bump map you can really add a lot of detail without actually adding any information to the geometry of your model. The way this works essentially, instead of actually deforming your geometry, you might have an object that's just a single polygon and you want that to be really rough. Well, it can't displace the points on the polygon because there's not enough information there to actually make a big difference. So it actually, what it does is inside that polygon, it changes that normal. If you remember that normal we looked at in the modeler, where that flat plane, there's a normal sticking straight out, that's also showing the direction that the surface would reflect. Well, at the pixel level, we can perturb that normal as we go along to make it look like it's facing different directions. So it's really just a visual trick. You can see this if you look at the side of the object here. You'll notice that it's actually still a perfectly round sphere. If I disable the texture, you see the boundary of that surface doesn't change at all. If I turn it back on, it looks like on the inside this thing is really rough, and so you'd expect it to be really rough on the outsides as well, but it's just a visual trick to make it look rough when really there's nothing going on there at all. But it's a great fast way to add detail to a model, and most people would never pick up the fact that it's just a bump map. Some people would. In that case, you can use displacement maps, or in cases where you really need the detail, you just add a little extra geometry in your model file itself. Okay, now you'll notice I was setting a texture value here, which adjusts the height of the bump. Okay? Now there's also a setting on the main panel. If I say use texture here, you'll see I've got the bump map value here as well, and you'll notice it does the same thing. So you might ask, hey Brad, why the redundancy? Well, I'll tell you why the redundancy. Let's just take a look. You may have a texture, let's just come back in here, and we'll add another layer. And we'll make this one a procedural, and we'll say it's going to be maybe the dots texture. Give a little bit of fuzzy edge width. And let's just reduce the size a little, like this. And we'll set it up to like 150. Okay, so you can start to see some little dots poking out here and there from our dots texture. Let's go down to this one and reduce the layer opacity. Okay, now you can really start to see them. So see, you've got the dots here that I just added, and you've got the crumple on the outside. But if I want to change the amount of that bump, I don't want to go to this layer and set a smaller texture layer value. I don't want to have to go to this one and set a texture value. So I'll come to the outside, and this is a global bump setting. So I can say, oh, that's everything in relation to the other looks great. The crumple looks great versus the dots. But I want the overall bump effect to drop. So we'll just cut that by half. And now both bump surfaces are reduced in amplitude. So that's how we work with procedural textures and a little bit about gradients. Now there's another layer type called image mapping, and this is where we take a still image like a JPEG or a Targa or a moving sequence like a QuickTime movie or an AVI file, and we apply that to the surface. Now there are advantages to procedurals and advantages to image maps. Image maps are much faster to render because procedurals have to be generated on the fly. The advantage to procedurals is you never have any seams or edges. So for in the case of like the fractal turbulence, they're moving through the object, I don't have to worry about the edges of a sequence or the edges of the image or the beginning and end of a sequence of frames because that is generated at each frame at the time of render. So depending on what you're trying to go for, procedurals are more accurate and they don't have a problem with tiling, but they take a little longer to generate. Image maps, you're limited to what you've got in the image, but of course they render much more quickly. Let's go ahead and take a look at the different types of image mapping and how we control those settings. Okay, first of all, I'm going to come back out, turn off my two panels here again with the tab key. So just hit the tab key quickly, and that will hide these windows. And I'm going to go back to my camera number 1, and let's just push that camera in just a little bit. I like this angle, but I want to be a little closer to it. And we'll go ahead and make a quick render there. Alrighty. And very nice. You can see this surface looking very cool. Those different textures on there. Now let's go back to our surface editor, and we'll go ahead and render with Viper. And at this point, I think we can set our backdrop back to use layout settings. Okay, looks a little better. Let's go ahead and remove the texture from the bump, and let's go ahead and make this back to red, a little red sphere there. Okay, so now we're back to where we were. You can see with our Viper looking pretty cool there. Now what I want to do is I want to pick one of these surfaces for a texture map. Let's go ahead and start with the cylinder here. So I'm going to go ahead and pick that surface. And actually, no, I'm going to start with the ground here instead. So I'm going to click on it, and that picks the ground plane. We can see here, ground plane is selected. We'll go into the texture, and you'll notice the texture is set to a procedural. It's set to use the checkerboard procedural. Well, instead, I'm going to set it to image map. And now you can see nothing's going on the surface because, of course, we have no image map chosen. So to do that, we'll say load image here on the image pop-up. And let's back out to our standard LightWave directory. Go into the images, and let's just pick logos. My favorite, the video toaster logo. All right, so that brings it in. And immediately you can see something very wacky going on here. Let's just go ahead and render that out. All right, now here's the image. That's what we'd expect to see on the surface here, but instead we're getting this really crazy, it looks like some pants I had back in the 70s. Really wacky texture going on there. And that is because our mapping axis is wrong. You see your texture axis here, you can choose X, Y, or Z. Now essentially what you're doing with your texture axis is you're painting, or you're choosing the direction at which your paint is being applied. So you've got X axis, which goes right to left, so your paint would be applied to your surface this way. You've got Z-axis, which goes forward and back, so that would apply to your surface this way. You've got Y-axis, which goes up and down, which would apply to your surface this way. Now the ground plane, obviously, you want to pour the paint on the Y-axis. All right? So our ground plane is this way, and we're painting along the Z right now. It's basically smearing one edge of that texture all the way across the surface. Kind of cool if you want that effect, but what we really want to do is we want to have it on the Y-axis. So I simply click on the Y-axis, and boom, you can see now my texture is applied in the appropriate orientation. This is actually a very cool way to work with Viper here, because I simply just choose the axis and I can see exactly how it's going to apply each different way. Now in this case you can see the texture is massively tiled. You can also see a really cool view here in the OpenGL perspective. Looks pretty neat. Let's go back out. But I want this to fit perfectly on that surface, so I'll just go here and I'll hit automatic sizing, and that will read the scale of the overall polygon here and then assign this map appropriately. So we hit that, boom, and now you can see our nice big toaster logo applied on that Z-axis, excuse me, on the Y-axis, up and down. Now there's another nice setting we've got here, is texture anti-aliasing. If we turn that off, basically you notice back in the background here, your texture starts to get a little bit pixelated. Texture anti-aliasing will smooth that out. So on the way back, it employs a technique called MIP mapping, where it goes in and it filters the image based on how far away from the camera you are. Okay, so that explains planar mapping, choosing between X, Y, or Z axis. But there's also different types of projection modes. You have planar, we also have spherical, cylindrical, cubic, front, and UV. Let's take a look at how these different mapping modes will affect our image. So we come back out here, and we'll say, let's map the cylinder here. So we click on that, and immediately you can see I've got my cylinder selected. Very handy way to pick things. We'll go into the color channel here. In fact, let's just go into the diffuse channel instead. We'll say diffuse channel, texture, image map. Again, we're going to load up an image. Let's load a little different one here. Let's go with the Toaster 4000 logo and make a render here. And now you can see that I'm varying the diffuse setting based on this image map. Now in this case we're using planar again, and because we're on the Z-axis, remember the Z-axis goes to and from the camera, so it actually maps pretty nicely. If I set automatic sizing, you see now my diffuse is being changed by this map that's mapped appropriately onto that cylinder. Now the problem with the planar map is that it's actually shooting it here and it's getting a weird deformation. What I really want, since this shape is more of a cylinder, is to change this to a cylindrical map. Okay, and again we'll automatically size that. Now what I want to do is change my width wrap amount to 2, so I get it on the front and the back. And what I also need to do now is change my rotation here. So if I just go to my heading rotation, I can just rotate this around. You can see how I can rotate it. And I can see something that I've chosen the wrong axis. Alright, so you can see now it's mapped along the z-axis, so it's actually mapping the cylinder toward and away from the camera. If I change this to y, you see now it maps appropriately. Now sometimes it's a little bit tricky to know which axis you need to map on. So it'd be nice if you had sort of a texture guide or a way to see that visually, a little widget. Well, if you're texturing in Modeler, we have just that type of tool. Let's go ahead and take a look at how we would do that. We'll go ahead and disable our windows by hitting the Tab key. And now what I can do is I can use my Modeler button here, and because of Hub, Modeler will come active, and it's already got my models in place for me for editing. So I can see my different layers, 1, 2, 3 layers of that one object. I'm going to work on this object here, and we can see our surface there already with a diffusion texture applied to it. I'm going to go ahead and select the map menu up here and use a tool called Texture Guide. So we'll choose that, and what you can see is now I've got a little widget for placing my texture. You can see I can move it in the window here. What we want to do is open up our surface editor, tell it which surface we're editing, so we'll go to the cylinder here, and now if we go into our diffuse channel, you can see that by changing the type, it also changes my texture guide. So here we can see I've got it set to cylindrical. If I want it set to planar, you see that goes to planar. And now, remember earlier when I had the wrong planar mapping axis? Now you can really see the difference. So here's Y, and you notice it's projecting on the Y texture. You can see that on your panel here. If I change it to X, you see now my projection is on the X axis. If I go to Z axis, it changes to this projection. If I go to Y axis, it changes that projection. So it makes it much easier to determine which axis mapping plane you should use. Now again, because this is a cylinder object, we know that we probably want to use a cylindrical projection. So we go here, and again, you'll notice that that's the completely wrong axis. So let's do an experiment. Is it X? Nope, that looks wrong also. How about Y? And there it is. You can see now the cylinder matching the cylinder widget on the same axis. And you can grab the widget up here as well for changing the number of wraps that it does. So if I grab this and just start spinning it out, you can change the size. And you can see as I scale it out, it tiles the surface over and over again. And you'll notice that it's changing my width wrap amount by grabbing and dragging on that. If I want to change the center, you can do that as well. The other projection types, spherical, obviously going to give you a sphere. Cubic is going to give you a nice cubic widget. This is going to project from all 6 faces of the cube. Not a bad choice for this cylinder also. And of course front is actually just going to project from the camera's view, so you won't see that with the widget. So cubic, spherical, cylindrical, make sure you've got your width wrap set, and of course planar. So a great way to quickly set textures in Modeler. Now the nice thing is once that's set, just go ahead and say we want that set there. Now when I come back into layout, my texture has already been set for me. So you can see by using the hub, we've really enhanced the workflow between the two environments. Now when we're working on a model file, when we go to our animation module, those updates are already there. It's a really great way to work. However, there's the caveat that that data hasn't been saved. So you have to make sure that when you're traveling back and forth between layout and modeler, keep in mind that periodically you'll want to save your model file and save your scene file. Even though the data is being transmitted back and forth between the two apps, it hasn't updated the file on disk. Now there's two other projection types. One is UV and one is front projection. These are a little bit more advanced techniques, so we'll save those for a later tape. But basically, front projection mapping is projecting the image through the camera's perspective. Similar to a planar projection map, but rather than choosing X, Y, or Z, it's projecting it from the projection angle of the camera. This is very useful for compositing. UV mapping is a way to discretely define which points align where on the image map. So it gives you a very accurate way of going in and assigning the texture map specifically to certain areas of the model. So a little bit more work, but it allows you to get very specific with the texturing of your object. All right, let's go ahead and take a look now at gradient parameters. Okay, for gradients, let's get something a little bit more interesting here. Let's go ahead and clear the scene. And go to your options, the O on your keyboard. Change your content directory out of volumetrics, down to landscape. Say OK. And we're going to go ahead and load the scene. And here you see we have a simple little landscape. This is actually a subdivision patch object that's using a displacement texture that's actually displacing the geometry. If we go to our side view here, you can actually see that that's a polygon that's been displaced with a fractal turbulence. But that's not what we care about right now. We're going to take a look at the surfaces. So let's go ahead and make sure our Viper is enabled. Let me go to my camera down at the bottom here, item properties, and let's make sure anti-aliasing is turned off. That looks good. 50%. Okay, nice low res. Now we can render that very quickly. And what we'll see is this surface, instead of looking like this dull brown here, has a lot of detail already going on. All right, so let's pick that apart and see exactly how that's happening, because this is all generated without image maps. This is using gradients entirely. Let's go ahead and take a look at our surface editor. Bring that up. If we go ahead and make a render, you can see we've got a very complex looking surface already applied to this object. Well, in the interest of education, let's go ahead and clear all those out. So what I'm going to do is just hold down my Shift key again, as I showed you earlier. With Shift key down, I can click on the different textures, and that's going to remove them. So I'll just remove all that, all the way down, bump channel, everything, and we're left with just our original flat shaded mountainous terrain here. So what I'm going to do is I'm going to use a gradient to create a surface for this entire object. So we go to our color section here, and under the T button, go texture. Again, change this to gradient. And now I'm going to change the gradient to y distance to the object. Okay, so it's reading from the 0 plane on up. And what I need to do is I need to figure out what the peaks and valleys are on this object. So hit the tab key to hide this panel again. And we'll go ahead and go to our side view here. And you can see that my grid size is set to 500 millimeters, or half meter. So this goes from 0 up to almost a half meter. So now we can go back into our surface editor and make sure that our end value is half a meter. All right. So what I want to do now is start creating some keyframes for the varying height settings. So first of all, we'll create a nice blue, and you can see now it's blue. And we'll go up to here and maybe make sort of a sandy brown color, like this. And you see now it goes from the blue to that sandy brown. We can decrease the height just by dragging this down like that. Create another keyframe in here. Let's make this one a little bit more green, like so. See, so we go from the blue ocean into the sandy beach, up to the green forest. Then we're going to go up here to a little darker brown area. Extract some of the red out of there. And we're going to raise that up a little higher so we get a little bit more green zone. So you see how easy it is just to sort of tweak these around and create some pretty interesting surfaces. And then the mountain caps up here, we're going to say those are going to be white, kind of a dingy white, like this. And now you can see we're starting to get some mountain caps. Let's go ahead and bring that brown down a little bit. There we go. So you're starting to see now, just by using the y distance to the object, since I've chosen none for the object, it used itself, it's changing the color of the surface as it goes from the 0 plane on up to the peaks of the mountains. Now there's lots of other things we can use on our input parameters. For example, we can use the incidence angle. We showed you those earlier on the color channel. You can also do some real interesting things with those on aspects or on parameters such as the reflection or transparency. Earlier when we were talking about the plugin for Real Fresnel, we talked about how transparencies and reflections could vary based on the camera's angle to that surface. Well, now you can do the same thing with a gradient and get a much finer control. Let's go ahead and take a look at how we can set up an interesting surface with that. Go ahead and clear our scene again. And let's change our content directory once again. We'll hit the O key, hit the content directory, back out a directory, and there's a new objects directory. So open that up, close that. We're going to go to Items, Add, Load Object, and just grab the Terran head. And let's go into our camera's view. And let's go ahead and move our camera by choosing camera down here. And then going to move. Let's move this over a bit like this. And kind of rotate this up. Move it back down a little bit. Okay, very good. Now, once again, we'll go ahead and go to our surface editor. Let's just turn on smoothing for the skin there. A nice smooth surface. And we'll make a quick render. I'm just going to freeze that out. Very good. Bring up our Viper window. And again, you can see pretty generic looking surface there on the face. So what we're going to do is we're going to go into the diffuse channel, set a texture, and in this case it's going to be a gradient based on the incidence angle. And we'll go ahead and set the first value down to about 40. Create a key, set that down to 0. And you can see how its edge on goes up to 40. And as it gets closer to the face, it goes to black, which is actually 0% diffuse. Let's bring that up a little bit. Create a couple more keys here. So immediately you can see we've got a much more interesting looking surface just by creating a gradient ramp to go through the diffuse channel based on the camera's incidence angle. If we want to create sort of a chrome looking effect in there, we can just crank this up here, get kind of a streak. You can see immediately it creates some really cool looking effects just by setting up a gradient ramp on the incidence angle. And then as we animate this character, of course the incidence angle of those surfaces will change, and so will that diffuse pattern that we see through the face there. So you can see even with these two simple examples of gradients, you can really start to get the idea of the power behind the gradient texture engine. There's all kinds of cool effects you can do, but this just barely scratches the surface, so you'll start to unveil things as you experiment. Now the final thing I want to show you is how to do texture layer blending. There's several different blending modes. Right now all we've been using is additive. So let's go ahead and take a look at some of those different settings. Once again, we're going to clear out our scene here. So let's just clear the scene. We're going to change our content directory back to our little primitive scene. So O for options, content directory, back out to 6 projects, volumetrics. Looks good. Context menu, load scene, primitives, no ground fog. Okay, perfect. And looky there, my models still have their funky textures on them. That's fine. So what we're going to do is go to camera. We're going to move the camera in a little bit. A little closer view. Okay, make sure our render options have Viper enabled. Make a quick render. And here we can see, this time we get a little anti-aliasing. That's fine, rendering pretty fast. And once that's trapped, of course, we'll just jump into our texture editor. And first thing we'll do is disable these texture maps so we can have a clean, fresh start. Luckily, it's very simple to do, so doesn't that look nice? I thought so. Alright, so let's jump in here. Again, we've got our Viper window. Everything's all kosher there. We're going to go ahead and go to our cylinder by clicking on it. Disable the surface by holding down Shift. Click on that. Click on the ground. Hold down Shift. And we get back to our blue. If we want to get that blue checkered surface sample, we can go back to use our preset shelf. And there's our checkerboard right there. Go ahead and close this window. And you can see the size is a little small. So go into the T button, scale. Let's just try 1 meters cubes. That's pretty good. Let's try 2 meter cubes. Okay, perfect. So again, with Viper and the new texture editor, it's so easy to move around and get these things set up. But what I want to show you now is the texture layer blending. So you can see here, right now what we've got is a simple checkerboard pattern on the ground. I'm going to add another procedural. So say add layer, procedural. And this time it's a fractal noise. And you can see how immediately that just sort of dirties up the ground. This is kind of cool. Could just use a gray shade here on top. Now you can see we've got a dirty tiled floor. But what I want to do is actually use this for a different mode. Right now our blending mode here is set to normal. If I change that to, say, subtractive, instead of layering that gray on, it's extracting the color gray from there. Now if I change this, let's say I change it to blue, it's essentially extracting the color blue from the layer before it. If I make it more of a greenish, you see it's extracting the green, leaving you with a more of a sort of purple or red shade. So that's how subtractive works. If you want to do a difference, it's basically taking the difference, or it's a divide between the two colors, which is sort of an odd effect. Let's go ahead and go with the solid green here. And you can see how the division there gives you a red. Multiply, is going to multiply one color times the other. Of course, this is just going to end up pretty much with a green. Divide there. Alpha channel and texture displacement. These are the most interesting of the batch. Okay? Additive you'll use most of the time. Alpha and texture displacement get really interesting. Alpha channel basically serves to clip away the texture above it. So if I put that one down below there, you can see that my alpha channel texture is now extracting color from that, that surface. So we can change, and let's add a little bit more contrast here. And let's go ahead and make it solid white. Okay, so you can see it's subtracting an alpha channel back to the original texture there. This is a real good way if we want to have multiple textures stacked, and we want to cut one texture out of another. You just put one alpha channel in between them. Then you can have like an image map, a checkerboard, and another image map, and then you'd see the two images together composited by that checkerboard. The final blending mode is displacement, and this is a real wacky one. What it does is it creates a 2D displacement of the original image. So you see here, if we disable that, our nice straight lines on our texture, if I enable it, you'll see the fractal pattern is actually displacing the straight lines. So it's actually in a two-dimensional fashion distorting the texture. You can decrease the size a little bit. See how that kind of stomps in there. Let's go ahead and change to a different type. Let's go here to crumple. And you can see how it roughs up the edges to give you a nice looking effect. So as you can see, we're just starting to scratch the surface, no pun intended, of the layering capabilities. You can obviously layer surfaces to an infinite degree. And the nice thing is, by combining texture map layers, procedural layers, gradient layers all together with those very interesting blending modes, you can create some really fantastic looking surfaces. Now this about covers it for the basics of LightWave 3D texturing. In subsequent tapes we'll be covering things like UV mapping, front projections, more advanced gradient control, using null objects as references, and many other advanced topics such as just creating much more interesting looking surfaces. Well, we hope you've enjoyed this first shot at LightWave 3D texturing, and until next time, keep on rendering.